Our next speaker, Prasanjit Singh, is the Director, Cloud and DevOps at Starsplay, Dubai. He's an expert in infrastructure, modernization, and DevOps enablement. Prasanjit has worked extensively on implementing cloud, DevOps, and ML practices to improve customer experience for large enterprises globally. Prasanjit holds a master's in information technology and has taught several courses on computer science technology, engineering, and mathematics to over 30,000 plus students worldwide at Coursera and MOOCs. You can find out more Prasanjit and his mission at www.binpipe.org. Watch learning video sessions at youtube.binpipe.org and read his blogs at blog.binpipe.org. His session title is on mathematics and metrics for DevOps and SRE.
Hello and welcome to DevOps India Summit. My name is Prasanjit Singh and today I'll be discussing DevOps in numbers. So we'll be moving on to discuss about the mathematics and metrics that are behind maintaining a healthy DevOps practice. Before we begin, let me quickly introduce myself. I am the Director of Cloud and DevOps at Starsplay in Dubai. I am also the instructor and SME at Coursera, so I create DevOps and container courses for them. And I'm associated with various cloud communities. I'm a community builder at AWS and with Cloud Customer Engineering community. I have spoken at KubeCon, so I'm a CNCF speaker as well, and I published a couple of papers about cloud autoscaling, and I have a YouTube channel where I teach about DevOps and the cloud. So that is about me. So what are we going to discuss today? So where are we headed? We will essentially touch upon 4 points. One of them is what DevOps is from the perspective of measuring DevOps, like why we would need DevOps practices and why we need to measure those practices. So what are those? And then we will also discuss if there are any metrics that are already available that tell us about the DevOps success or the success of our continuous delivery pipelines. So we'll discuss that. And we'll discuss the hows, like how do we measure, how do we get into the calculations to know whether a DevOps process is moving towards a success or whether it is not adding value to the team. And I'll follow it up with a quick hands-on. So I'll just demonstrate how this is to be done when you're hosting your DevOps pipelines in the cloud. So that is what we are going to discuss. Now, what is DevOps? Now, as we all have heard about the analogy, the story about the elephant and the blindfolded man, like different blindfolded men touch different parts of the elephant and they think, like someone touches the trunk and thinks it's a rope, someone touches the tail and thinks it's a snake, and so on. So similarly, DevOps means different things to different people. So what is DevOps essentially? So I believe DevOps is a cult. It's not just like a few things like tools or practices. It's a cult, like those who believe in DevOps practices, believe in that culture of DevOps. So there are basically 5 things that I found important behind the DevOps philosophy. So one is as we all know, DevOps helps in collaboration. DevOps believes in breaking the silos in different teams. Like if you are an organization producing software and you have developers, you have ops guys, system admins, you have quality, security engineers. So all do not need to work on their own in different siloed manner. So there should be collaboration, and that adds value. So that is the first thing DevOps is. It reduces the organizational silos. So that's the culture which DevOps brings in. Then next is DevOps encourages you to accept failures as normal, because if we fail fast, we quickly recover, and we learn the steps to recover and don't make the same mistake again. So that is another thing that DevOps is. It's the culture which encourages failing fast and recovering from it. I'm telling you these points because these are the tenets of DevOps which we will measure eventually and understand, like how measuring helps in actually endorsing the capabilities of DevOps. So the third thing that DevOps brings in is it encourages incremental changes. So what is that? When we practice DevOps, we do not make big changes in one go. No rapid transformation. We'll go by steps, we'll go by increments. So in that manner, you can, as I said, fail fast, you can quickly recover, you don't make a big mistake when you're running in a production and lots of stakes are on you. And if you're serving a traffic in huge numbers, like say you are a website which serves millions of users. So in those cases, incremental deployments, incremental releases helps a lot. So that is another thing. The fourth point DevOps is about tools and automation. Most people normally think DevOps is about learning Jenkins or pipelines or Ansible or Terraform. So it's this is just one part of DevOps where we encourage having tools so that we deliver fast and we deliver reliable software. So that is another important part, automation and using the right tools. And the final point that DevOps is, it encourages measuring everything, because if we measure something, it's only then we can manage it, we can improve it. Like if we do not measure, we don't know where we are. And say, for example, when people say a website is slow, so what does that mean? And if you fix it and the next time he says, you ask like, is it fast enough? They say, no, it's same, it's slow. So in these cases, if you do not measure it, you do not exactly know whether any improvement was made because of the change that we did. So measuring is very important. Well, now, what is DevOps? Continuing that theme, basically it's a full life cycle investment. Like it's a culture you bring into your organization, and that goes on for the entire life cycle of your DevOps processes or your software release life cycle. So we are all aware of the infinite loop model in DevOps. So we plan, then we code, then we deploy, and then we monitor, and then if there are any issues, we get the feedback, and then we go on the same loop again and again. So DevOps is about continuity. Like you continuously integrate your code, you continuously test, you continuously deploy, and it is important for teams to also continuously measure, monitor as well as measure. So if you're measuring your success, then you really know you're going on the right track. if you're not measuring, then you would be just going with the flow, like everyone is doing DevOps, so let's jump into the bandwagon. But measuring is very important. That's why, like, because every organization, every delivery process is different. So you have to tune into your own software practices and improve that, so that you have to measure. So I'll drop you some hints on what to measure and how. So why we are going to measure it? As I already touched upon a few points, like there are multiple reasons, but basically there are three things: inspect, to improvise, and to improve. Now I'll explain you what these are. First, if we measure DevOps, we will be able to look closely at our processes and understand the small changes that come in for, like, if we introduce a small change, what effect does it have? That cause and effect can be understood properly if we measure DevOps. So it helps us to inspect. And then measuring DevOps allows you to improvise on runtime, because DevOps is not just about the culture and the practices that you discuss. You have to practice it when you are in the industry and doing real things, really deploying software using DevOps. Then you have situations where you have to improvise, like, say you have a huge traffic coming in suddenly, say it was a Black Friday, or there was a soccer match going on, and you had a huge traffic on your website, and you have to handle that. Say you were not prepared for that, and suddenly your website goes slow. But since you are a DevOps practitioner, you have tools at your disposal. You have Terraform, you have Ansible, you can scale up your stack and so on using these DevOps practices. But did it help? Was it economical? Was it adding value to the business, or we were just spending money on over engineering things? So these things become important when you are in a real world industry practicing DevOps. It's not just about discussing the culture or practices in the books. So in those cases, you need to improvise sometimes. Like as I gave you the example of having a huge traffic suddenly out of nowhere, and you have your scripts and practices, but how much to scale? Should I make it 100 servers, or just 50 servers would be enough for that capacity of traffic? So measuring is important, and that allows you to improvise. Like on the go, you can change the parameters in your Terraform and scale up to a certain limit that is required for that particular use case. So that is improvising, and obviously improving. As we said, like DevOps encourages you to fail fast. So you fail and quickly fix things and make it a practice for the next time. Because in DevOps, we believe in automating everything. So if something failed and we fixed it, and whatever we did manually, we had to put it on a script or make it a policy and apply it, so that next time the same issue happens, it is taken care of and we move on to the next problem. So it allows you to continuously improve as a part of the DevOps culture. And measuring is important because data brings in insights. So you get insights, then you know what to do, what decision to take. It's not just like you should not just believe in, okay, I have huge traffic, I'll scale up my servers. But how much to scale? What are the parameters should I measure? For example, let me tell you an example. People are normally obsessed, like I have been a system admin for 10 years, so I know, like we are normally obsessed, hey, how much spike is there in the memory or CPU when an application is being monitored? We say, hey, site is slow, check the CPU, check the load average. Like, but DevOps doesn't encourage this kind of thought process. DevOps encourages on measuring the parameters that really add value to the end user. For example, if the user is viewing a website and the website is slow, the user experience is not good. So what should we focus on? We should focus on the response time of the website rather than how much CPU. The user doesn't care if you're on 100% CPU or 60%. So you should first focus on measuring the response time of the application, because that is directly connected to your customer. And then if you dig deep, like if it is slow and response times are higher, then why? Then what to measure? Then you go on to measure the memory, CPU, whether you're using a cache or not, how much space is left in the cache, and what is the size of the images there on the website, or if the video streaming is done from the nearest CDN or not. So those are the secondary things. So basically we should focus on the metrics which are directly connected to the experience. So that needs data to be collected and measured so that we really come upon insights that help. So how do we do that? So as I said, to measure DevOps, we need to decide on the metrics, which metrics needed to be measured to add value, because there are hundreds of metrics that might not be useful. I have seen DevOps articles where people even measure the lines of code, like how many lines of code are there. That means that much productivity that team has added. But in modern day applications, these things do not matter much. Like we are not, this is an IT industry. It doesn't work like any other normal industry where you quantify your work by amount of commits made to the repository or so on. So here what matters is whatever was committed, was that efficient. So rather than measuring the lines of code, it would be better to measure things like say how much time it took to build and deploy, like how much time was there between the time the code was triggered until the time it reached production, or how much time was taken for the application to recover from a failure, because these are directly related to the user experience. Say a failure happens, how capable is the DevOps team with its tools and practices and automation and all the culture to quickly revert back or roll back to the previous version and get the business back into operation. So that is where all the things that we preach about in DevOps really adds value to the business. So deciding on the metrics is really important. What to measure, not just fill up dashboards with lots of things, because yeah, digging deep or deep dives are needed, but not always. If everything is fine, it's fine. If something is going wrong, then we deep dive into the other metrics. But the initial look, like what without getting confused about metrics, what should be the initial 4 or 5 things that we should look in a DevOps dashboard to know whether we are on the right track or we are missing out. So that is about deciding the metrics. So I'll tell you what those metrics are and how they are measured and why they are important in a while. And then comes deciding on observability practices. That is also like the same theme that we measured, like deciding on the metrics and how do you practice observing that. There are multiple ways you can observe. For example, I can just SSH into a Linux server and run a top command and see what processes are running, or what is the memory, what is the CPU going on, or how many PIDs or how many threads of a particular process is running. So that can be done. But is it a good way to do it? Is it universal? Like everyone might not be a Linux admin like us. So there are QA people in the team. We have developers who might be more comfortable looking into a real-time dashboard. So what practice you're using to observe is also important, and a responsibility of the DevOps team to put those practices across for the entire organization, so that everyone is aware and onboarded, like what is going on, everyone knows, so that they can contribute and help in collaboration. And finally, deciding on the outcome analysis, like whatever you see on the dashboard, you should be able to interpret it. You should be able to know what that means, and not just have an idea, okay, when this goes 100, something is wrong. When this is below 30, we are good. So it should not be that way. You should know the reason behind every metric, because it changes from organization to organization. It changes from companies to companies, applications to applications. So there is no fixed metric that a particular value should be a fixed number that you commit to memory. So you should be able to analyze those things that you measure in DevOps. Now, what are the major metrics that are measured in course of a DevOps life cycle? So there are 4 key metrics. So they are known as 4 keys, very popular. And this term has been coined by DORA. Now, DORA is a organization, DevOps Research and Assessment. It's a team of people who survey about DevOps practices throughout the globe, and they come up with recommendations. So these are the 4 keys that are recommended by DORA, and it is backed by large organizations like Google, who participate in these surveys, and they support this project. So we come across 4 keys that essentially are required for measuring DevOps success. So the first one is the lead time for changes. As I said, it's the like when we deliver software to customers, it is important to measure the amount of time that a commit takes to get into production. So lead time is that time. So from the time the developer commits the code on repo, GitHub, Bitbucket, any version control repository, to the time when that particular commit goes into production. So that commit becomes a part of the package when it is built and finally deployed to production. So that interval is the lead time. So it tells us a lot. Like, I'll discuss more about the interpretations towards the end. So for now, just commit into your memory, like lead time is the time for a commit going into production. So a change goes into production, the time that takes is the lead time. Second is the deployment frequency. Like how often, the name is self-explanatory. How often do we deploy, or are we able to deploy? Because this involves a lots of internal squads in the team to deploy something a single person cannot do. So here it's real DevOps in action. Like, you have developers who know about DevOps practices, they commit it, and then we have automated test cases written. We have DevOps engineers who build a pipeline to deploy that, build and deploy that finally. We have tools and practices involved there, and we have test cases and test teams to take care of the releases, whether everything is fine or not, whether there is a bug and needs to be rechecked, or if everything is fine, it should be passed on as a release. So the entirety takes involvement of lots of different squads in the team. So the time taken to deploy, like how often we can deploy these releases successfully, is the deployment frequency. Failures are not counted here, because here we are counting the success of a deployment. Now, for failure, we have another metric. I'll come in the end. Now, if there is a failure, we measure another metric called mean time to restore. That is the average time you take to restore. Now, we don't, because see, normally when failures happen in real production environments, it depends on the nature of failures. say some failures might take 40 minutes to restore, some failures may take 5 minutes to restore. So there is no fixed value. So you cannot say, okay, if a failure happens and if you don't fix it within 5 minutes, it's a bad, it's a red signal. So that's not a very good way to manage uh, in a DevOps way. So in DevOps, what we do is we take metrics for a span of a month normally, and we calculate the mean time to we took to restore those failures that happened over a month. Okay, and the lesser these failures, the better. Like lesser time you take to restore is better. And if you are really practicing DevOps, believe me, it takes less time, because we can roll back. We have rollback features in the pipelines. We can if something goes wrong with the infra, we can rebuild the infra, because we have Terraform or Ansible or these kind of infrastructure as code practices. So we have tools at our disposal to reduce the mean time to restore. And then finally comes the change fail percentage. Now, what is the change fail percentage? It is nothing but the failure rate, like change failure rate. It is the percentage of deployments causing a failure in production. Like how many deployments went bad. That's something which I was discussing some time ago when I talked about deployment frequency. So deployment frequency is the deployments that went good. Change failure percentage is deployments that went bad. So if there are more of change fail percentage increases, that means something is wrong either with your coding, like the way we are doing our unit tests after we code. So because we are not catching it early, it's getting failed during the deployment. So unit tests should be improved. We should add some test cases, because in DevOps, we shift everything left. We do it beforehand so that the deployments and going into production and post deployment issues are minimized, and there is a good experience after we arrive at production. So change failure rate tells us about that, whether we need to fix some processes in order to handle failures. Now, coming back to the metrics and who recommended them, as I already said, like DevOps Research and Assessment Group has recommended this, and based on this, we also decide like how mature our DevOps practices. So organizations can answer this is a self questionnaire for organization, like are you failing multiple times per day or multiple times per month or week? So based on that, you can know how good performer you are. So for each of the metrics, you have a questionnaire which you can self assess and understand where you stand. Now, it takes time for an organization to mature from a low IT performer to a high IT and adopting the DevOps practices. It takes some time, because it's not about just taking some tools and putting it up there. It's about each person being as passionate as we all are who are involved in DevOps, and to understand like these are a set of things that will really help improve. And it's not just something that the manager told us to do. So people should not take it that way, that I'm building a pipeline and deploying it through a pipeline because the manager told me. I would have rather done it manually, copied the jar file into production and run it there. It's just 3 commands. So it should not be that way, because if you put it into a culture and a practice, only then everyone follows it. You can measure it, you can benefit out of it. So that's the real idea of doing the assessments and measuring DevOps. Okay, so we calculate the metrics, and we also, by the metrics, I mean the 4 keys that I discussed some time ago, and we put them up in dashboards so that it's easy for everyone to see and interpret. Now, how to prepare those dashboards and how to build them? What are the normal practices? Because there is no standard practice as such, because everyone is in a different environment. Someone is deploying on Amazon cloud, someone on Google cloud, someone is using OpenStack or open source software, someone is deploying their softwares on premise. So you would not have a single dashboard where you can accommodate all these use cases. So the idea of me showing you this is understanding what to measure and how you can put it up there. And I'll show you a couple of demos how these dashboards are made, so that if you want, you can do that yourself if you are not measuring it. And again, it's not necessary to have this dashboard to practice measurement in DevOps. You can even do it with a Excel sheet, with a spreadsheet. So it can be done. You just have to understand what to measure and how to measure. That's it. Now, this is one dashboard by the 4Keys project. So there they measure the daily lead time to change, as I said, the median lead time to change, like how long does it take for commits to go to production, then the change failure rate, the median time to restore, like how much time you take to get back, and the daily deployment frequency. So if you can deploy more, that means you are more capable on DevOps practices, because say you make 4 deployments per day. Normal teams who do not practice DevOps would deploy maybe once a month. So it's that slow, because there what happens, those who are not practicing DevOps, there it will be more like a waterfall kind of a model. So dev teams will develop and throw it out to the test team to test, and then they move it on to the ops team who doesn't understand how that code works. They get back to the dev team to understand how to build it and deploy it on production. Then there it goes and doesn't work because some environment variable is missing. So there is no real collaboration. So when practicing DevOps and real collaboration happens, then your deployment count grows. Like you can deploy multiple things in one day. So then this metric will help you understand your maturity in terms of DevOps capabilities. So then you know, okay, I'm doing well. I have made 6 deployments to production today itself. 2 of them failed. No worries. I had a script to roll it back. So you get the metrics from there, and you know how much time you took to restore for those rollbacks. You can measure that as well. So that way you really represent to the management or your team or your organization that DevOps team is adding value. These practices are adding value. They are not just from the books or being preached by people. They're really adding value, and it has added value to thousands of companies worldwide. So those who are watching this and still question capabilities of DevOps can start practicing DevOps and measuring them. All right, let's move on to a quick demonstration on how to build these dashboards and how it works. So we will share in the final slide the links to these repositories which you can use for the code. So here, once you get into this repository, you can just check out the code, like copy the link from here and clone it, do a git clone, and you will get this code in your own laptop, and follow the steps I have mentioned here. Like you will unzip all the code that you got it and zip it into a file called pipeline dashboard with these contents, src and test, that is present here. Okay. And then if you are on AWS cloud and practicing how to prepare this dashboard, then here are the commands and how to run them. You have to install AWS CLI on your terminal and just copy paste these commands. So everything is ready for you. Just copy paste these commands and make sure to have your AWS command line connected to your AWS account. So once you create this creates some S3 buckets where it keeps all the information related to your pipeline dashboard. And finally, you have to run this command, CloudFormation create stack. So this command, what it does is it creates that dashboard for you. Okay. So how will it look like when you run that command? I have already created it. So once you run that command and search for CloudWatch, so you will see there are certain dashboards in CloudWatch that has been already created, because this command will actually do a cloud formation. So it will create a stack called pipeline dashboard. And then we have some templates here, which I have already included here, this template.yaml file. So this will create a dashboard for us. And the dashboard will look something like this. Pipelines dashboard, okay, here. So this is how it will look like. Now it has certain metrics. Now what are these columns here? And what are these rows? Let me quickly tell you. Now these columns show us the cycle time, lead time, mean time before failure, the mean time to recover, and the feedback time. Okay, like how much the mean time for failed executions. It's the same metrics that we talked about some time ago. So here it's not as a graph, this is a simple one, so it just gives you the numbers. So from that number, you know, okay, project alpha is a pipeline that is taking 6 minutes to build, like from the time the commit is made to deployment. The lead time is this much seconds, so your pipeline execution is taking this much time. And there were no failures, so nothing is populated. This is just a demo, so not everything is populated. So this is how it will tell you. And how do you connect your dashboard to your pipelines? Say you are using AWS, you will be creating your pipelines here. Like when you do a create pipeline, you go and name a pipeline, say test pipeline, and then you use the source, like from where your code is coming from. If it is, say for example, my code is coming from GitHub and I have connected my GitHub account, then it will ask you for the repository name that you want to build. Say I want to build this repository, say Blue Ocean. So it will tell me which branch you want to build and so on. So this is a demo, I'm just skipping the stages. So once you build and you tell which destination, where to deploy and so on, and then you create that pipeline, then that pipeline is automatically monitored by your CloudWatch. That is how it is built. So when this pipeline will be created and when we trigger a build, that will appear on this dashboard, like project alpha, beta, gamma is here. So you will see a project test pipeline as well when we do a deployment of this pipeline, or if we run a release of this pipeline. Now you can see it is in progress and deploy has succeeded. So after some time, this too will appear on our dashboard. Like this dashboard keeps on polling or getting metrics. So that is how it will work. Similarly, you can also use this project 4keys from Google. If you are working on Google Cloud, or if you use Tekton for your deployments, you can use this. So I'm just leaving you with the repo URL. So just 3 commands: Google Cloud config set and your project ID. Get into this setup folder and run this script. So that will build the entire dashboard for you, and you will have to run it through your Cloud Shell. This is a Google Cloud account, so just go into your Cloud Shell. So it will open a terminal for you here. And then inside the terminal, you have to run those 3 commands that I just mentioned here. These 3 in this terminal. That will be provisioned in a while. So here you will git clone the repository, go into that setup directory and run those 3 commands. Once you do that, you will see something like this, the 4keys dashboard. So this is the same dashboard that we discussed, where we discuss all these metrics and how to measure them. Now, very quickly, let me tell you like about the interpretations. Lead time to change, if it is high, that means you are taking more time to go into production. That means there is something that needs to be improved in your pipeline process. Maybe the developers are slow, or it is failing in test cases, or test cases are not automated, so manual testing is happening. That's why your lead time to change or reaching the end of the pipeline is taking time. Then failure rate, if failures are more, test cases are not designed properly, they are testing something which is not relevant, so you are getting more failures even after your test cases are running. So that way you can improve. Daily deployments, if you make more deployments, that means you are capable enough to really deploy and scale in production. And you are making more deployments means you are also making more mistakes and able to recover back. So that also can be seen here. So it is good to fail. If you don't have failures or nothing to restore, that means something is wrong. Like ideal thing should fail also, and then you measure like how quickly you could recover from that failure. So that was about the metrics and how we measure DevOps. So we leave you with these repository URLs from where you can try it yourself if you're using AWS or GCP. If you're not, then as I said, you don't need anything. You just need a spreadsheet to at least measure what you're doing. Like from the time the commit was made to the time the deployment was done, you can just note down those times, calculate the means over a period of time, and then know how efficient DevOps is. So that is it about me. Thank you. Thanks for staying with me and listening to the Measuring DevOps session.